Hey guys, welcome to this free lesson on transformations of functions. So we're going to be graphing things that are like this, and if you've never used my videos before, I highly recommend that you pause and try the examples when you are prompted to do so. Also, there are free guided notes available, and I think that they are really good for this lesson because I include graph paper and stuff like that. So if you want to check those out, you can go to divideandconquermath.com. Okay, so let's just start by talking about some basic graphs. So this might take us a little while to build, but this is a really worthwhile exercise. So where I want you to start here, I actually have on your guided notes 3 graphs that you should just kind of draw the basics of. So I have the same table listed for each graph. So I want you to find these 5 points that go into x squared, and then I want you to do this again for the absolute value of x, so same exercise here. And then also this one. And I want you just to think about kind of what's happening here. This will really help illustrate a few points, and I think it's best if you take the time to actually figure it out on your own and then hit play when you're ready to see kind of everything. So let's just start with x squared. You can fill in the table and then check. Okay, so as I square each thing here, so -2 squared is going to be 4, -1 squared is going to be 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So where I want to start is I want to plot all these points. So here's -2, 1, 2, 3, 4. So there's my first point. Here's -1, 1, 0, 0, 1, 1, and 2, 4. Okay, so what makes x squared what it is that it's this parabola shape. So this is called, we might want to just note that, this is a parabola. And so here's the thing about this, and here's kind of my philosophy of graphing in general. So whenever you take the time to kind of build these out and figure out the basic structure of a graph, you kind of want to note just some of the really basic characteristics about this. So it doesn't even have to be anything like super mathy or anything like that. So just looking at this looks like a U to me. And then also there's like a bottoming out point here, and then everything's kind of symmetrical on each side, right? And it's got this curved shape. So understanding graphs to this level will help make them easier to graph later on, which is super essential in this section. And I want to point out to you 3 really important points. The first one is this one, and then this one, and then this one. So I want you to actually kind of note these 3 to yourself. The idea here being that if I kind of know these 3 points, I can probably make a decent sketch of the graph. It won't be perfect, but probably for our purposes, it will get us kind of the gist of what we need. And the other thing I want you to notice about this, how do I get to each point? So I'm going to try to make this nice, and I'll use this pink color here. I start here at the bottom, and then notice what I do. I go out 1 and up 1 in each direction. So again, when you're trying to just graph tons and tons of graphs, noticing these little patterns are going to be really, really helpful. So I just want to point that out. So now let's do this again for the absolute value of x. So now I'm going to go ahead and evaluate these points. And if you haven't done this yet, pause the video, hit play when you're ready, try to graph everything. So if I plug these in, this is 2, 1, 0, 1, and 2. So I'll go ahead and graph these. So I have this point, this point, this point, this point, and this point. So again, you want to make sure you've kind of got this all down and draw this at your own pace. And so to make this graph, it's going to look like this. It's going to be in this V shape. So very, very similar to the last one, right? But this is a V, this last one was a U. And the 3 points I want to point out to you again, just ones that will kind of help us really get to that basic shape. These 3 points, if I know these 3 points and its absolute value means it's going to look like a V, and these 3 points will kind of be enough to get me where I need. And I want you to notice something. Once again, I start here at the bottom. Notice how I get to the next point. Out 1, up 1 in each direction. So it's literally the same as this previous one with the parabola. Started out at the bottom, went out 1 and up 1 in each direction, except a parabola is a U shape, so when it's squared, it's going to be a U shape. When I have the absolute value of x, it's going to be a V shape. Super, super essential to kind of just have this intuition about this. We're building intuition right now. Okay, so now we've got the square root of x, the last basic graph. So if I plug all of these values in, so I talked about this before, but it's worth mentioning again now. When you're talking about graphs, you can't actually take the square root of a negative number. It's because even though these two values might equal imaginary numbers, the problem is we have no way to graph them. So with imaginary numbers, context super matters. So here we just have to say that these don't exist, but I can evaluate these other three values. So this will be 0, 1, and then this will just be the square root of 2. All right, now that's not exactly helpful, and if you don't have a calculator with you, then you might not even know what that is. So now I'm going to extend my table, and I'm just going to think to myself, what is the next point that I could evaluate? So I could evaluate x equals 4, and then this would equal 2. So part of the reason why I like starting with these types of tables for graphs that maybe I don't know the shape of, this really helps me just to figure out some of the basic behavior of the graphs. With these previous two examples, with x squared I could evaluate all of these. With the absolute value of x I could evaluate all of these. But then everything changed when I got to the square root of x, and now I'm having these issues. So I always think that starting with these 5 points is like, it's a good place to start. It might not get you enough of the picture, but it just kind of helps you think through some of the finer details, and then you can go from there. So once again, now let's just graph the points that we can. So here's 0, 0, here's 1, 1, and here's 1, 2, 3, 4, 4, 2. Okay, so here's my x squared, and actually this needs to not slope down. I'll just draw that one more time. Okay, so here's my x squared. Now, in this case, I always make a terrible joke about this, but I'm always like, it's like a parabola. So it's kind of like this, but it's like a parabola that's really having a bad day. So it's like flopped over. It's only half there. This parabola is not doing very well. So there are really 2 points that you need in this case. These are the two, and then I have to again kind of know this is a parabola that's going out this direction. And so notice just how you get to these 2 points. I start at 0, 0, and then I go out 1 and up 1 only in one direction, right? And then I have to draw it going this way. So the whole thing about this lesson is that you kind of know the basic shapes of these graphs. Super essential for this. Okay, so now let's actually get into the meat of this lesson. And we're going to be using those graphs all the time. That's why I spent so much time talking about them. So I'm going to show you these 3 graphs. So I'm just going to draw these out for you. And then I want you to visually compare them. And you can also draw them on your own sheet of paper. That will probably help you to understand what it was that I actually did. So first I have just x squared. This is kind of where we're starting. And now what I want to see is what happens when I have x squared plus 3. I'll show you. Okay, so here's x squared plus 3. So notice what happened. It went up. Notice how much it went up. So here I started at 0, 0. Now I've basically bumped this graph up 1, 2, 3 spots. It's still the same shape, right? It's just moved up 3. Looks very, very similar to the number that I have added here, right? So this looks like a pattern. So now let's compare that to this last one here. I'll draw that. Okay, so now comparing what happened here. So again, the white graph is my x squared, and now at x squared minus 1, look what happened. It went down 1. So the fact that this went up 3, the pink one went up 3, and the green one went down 1, that is not a coincidence. That is actually the first transformation that we're investigating. That transformation is what's known as a vertical shift. And I have kind of the whole formal mathematical definition here. So given a graph of a function f of x, the function g of x equals f of x plus c, where c is a constant. So the graph of g of x will be the same as f of x, but vertically shifted c units. So the thing I really want to point out here is that this is the idea of a number falling outside of the function. So if you just have the function and then you add or subtract something to it, if you add something, it's going to move up. If you subtract something, it's going to move down. Okay, so I want to compare this now to my next example. So I'm going to do the same thing. First, let me just draw the absolute value of x. Okay, so there it is. So now notice how what I've done to these functions is a little bit different from the last one. In the first set, so I want to show you. So this is the idea of having a number added outside of the function. Now, with these, what I'm doing is I don't have, this isn't like having the -1 on the outside, right? Instead, what I have here for this one, this is like having the -1 kind of inside of the function. It's within the absolute value. So which way do you think this is going to move now? Up, down, left, or right? Think about it for a second and let me show you. Okay, so check it out. This moved the graph actually to the right. So maybe you were thinking it was going to move it to the left because it's negative, but this is actually going in the opposite direction. Okay, so maybe this went against our intuition, but it is what it is. So what do you think is going to happen now in this transformation? If I have absolute value of x plus 2, which way is it going to move? I'll show you. Okay, so now this moved to the left too. So to move a graph left or right, so you have to have this number kind of inside of the function. That's the way that I kind of think about it. And then whatever way you've got it, so if you subtract something, that'll move it to the right. If you add something, that'll move it to the left. So it kind of moves in the opposite direction. So I have this all summarized here, and this is kind of how we look at this from a mathematical standpoint. So you've got your function f of x, and then you've got this function g of x equals this f of x minus c. So I want you just to notice how this is different from what I was just telling you before. With a vertical shift, this is this idea of this number falling outside of the function versus a number being inside of the function. That's actually baked into those definitions. And when this happens, what you have is the graph getting horizontally shifted. The thing to remember, if you've got plus c, that means you're moving left. If you have minus c, that means that you're moving right. Okay, so let's table that for now. I want to show you one more transformation. So going back to absolute value, I'll draw the base function. And now I'll just show you what it means to be negative absolute value of x. So now I've effectively just flipped the whole thing over. And so this is the last transformation we're going to talk about. This is a reflection about the x-axis. So you take any function, if you just put a negative in front of that function, then you're going to get this reflection over the x-axis. Okay, so I know this is a lot I just threw at you. So now what I want to do is I want to actually kind of get you to understand how these transformations work. So I'm going to break this down in a few pieces here. So first of all, I've got this function, f of x equals the absolute value of x plus 3. So the first thing I just want you to get used to is describing what's happening with this. So this number, would we consider this number kind of inside of the function or outside of the function? This falls outside, so when it falls outside, it is going to fall into this vertical shift category. And so remember, with vertical shifts, plus c means up, minus c means down. So when I look at this, this is going to be the absolute value of x shifted up 3. Okay, so that's the first part of this. So now let's talk about how do we graph this. So now this is where I have to refer back to how do you actually draw the absolute value of x. Now remember, I told you there were 3 important points, so I'll point those out again. These 3 points, these were really the key ones. You start at 0, 0, and then you go out 1 in each direction and up 1 in each direction. That is super essential for this part. Now, instead of this starting at 0, 0, I know that I need to shift this up. 1, 2, 3. So here's my starting point. Now let me show you how to finish this. From this starting point, I'm supposed to go out 1 and up 1 in each direction to get to the other branches of the absolute value. So this is something I can only do because I've really studied and learned what that shape of the absolute value looks like. And then I know that it's also supposed to have this V shape. So once you really understand kind of just the basic structure of a graph, then when you start doing a transformation to it, you can basically take what you know about that general structure and then graph it out. Okay, so that's what we're going to be doing. Now, if you find this helpful so far, maybe consider liking my video or subscribing to my channel. That really helps me continue to put free math on the internet. Any comments you have too are fine. I know this is a bit of a longer video, but it's just, there's a lot of detail in this, so I kind of can't help it in this case. Okay, so now let's talk about these two graphs. So with this one, is this number falling, this -1, would we consider this inside the function or outside the function? This would be considered inside the function. So just as a reminder then, going back to this. So this actually will move then in the opposite direction. Plus c means that I move to the left, minus c means I move to the right. So in this case, this is going to move right 1. So that's what we want to note. Now, thinking about what I know about x squared started at 0, 0, but now instead I need to move it to the right 1. So here's where I start. Now, to create x squared, I said that I go out 1 in each direction and up 1 in each direction from this centering point. So I go out 1 and up 1 in each direction. Here we go, out 1, up 1, out 1, up 1. And now from here, what I can do is I can draw that U shape. So again, it's not like you can do this with just any graph. It's something where you've really spent some time intimately understanding some of these details. Okay, so I'll do another one of these with you. Actually, why don't you try this one? Maybe pause the video and determine which way does this move, up, down, left, or right, and then hit pause, hit play when you're ready. So this one, the number is falling outside of the function. So this is moving down 2. And so now what I need to do is I need to just remember what I know about the square root of x. So we said that the square root of x starts at 0, 0. So now I just need to move that down 1, 2. So here's where I'm starting. Then to get to the next point, I really go out 1 and up 1, and it has to swing to the right. So there you go. There's a pretty good drawing of the square root of x minus 2. Okay, so let's do like another one of these together. So now I've got kind of everything put together in one example. So why don't you pause the video and just write down how is this going to be transformed, up, down, left, or right? So in this case, so the plus 1 means that I'm going to move left 1. And then the minus 2 means that I'm going to move down 2. Okay, so now I can reflect that in my drawing. So I start here, so with absolute value, I know that normally I would start at 0, 0. So I'm starting here at 0, 0, but now I need to move left 1 and down 1, 2. So there's my first point. Okay, now from here, we already talked about this, right? You go out 1 and up 1 in each direction, like this. So let me mark those 2 points. I go out 1 and up 1 in each direction, and then it's absolute value, so it's got that V shape. So this is a pretty good drawing of what this graph would look like. Okay, so why don't you try this now for D on your own? Hit play when you're ready. Try to graph it too. So in this case, this is going to move to the right 2 and then up 4. So if I start here at 0, 0, now I'm going to move right 1, 2 and up 1, 2, 3, 4. Okay, great. So here's my first point. Then I know that I can go out 1 and up 1 in each direction. We talked about that. That's the general structure of this. And it's being squared, so it's a parabola. Therefore, it will have that U shape. So here's my U shape. Okie dokie. So now let's pivot to E here. And now I just want to show you what is the plot twist when I have this negative. Well, first things first, does this move left or right? It moves left 3. Does it move up or down? It moves down 2. And then it's also going to be, I just write flip for myself so that I know what I'm supposed to do, because that it's going to be reflected over the x-axis, right? There's that negative here now. So that's kind of what's throwing this all off. Okay, so you start this off business as usual. So what I'm going to do, I'm going to go to the left 3, 1, 2, 3, and that negative doesn't like change the directions or anything. Everything you've already learned about shifts and all that's all still good. So I go 1, 2, 3, and then I go down 1, 2. So there's my starting point. So now let's just talk about what does it mean when I have that negative there. Well, normally I would go out 1 and up 1 in each direction. But now with this negative, remember, I need this thing to now be flipped. So instead I'm going to go out 1, and instead of going up, I'm going to go down. So that's really the only thing. So now I'm going to go out 1 and down 1 in each direction. So I just reversed the direction. And other than that, it's still going to be that U-shaped, but that's how you get it to now open down. Okay, so why don't you try that now with F? Pause the video, hit play when you're ready. So in this case, I'm going to move left 3, I'm going to move down 1, and then I also need to flip. So I go left 1, 2, 3, I go down 1, and then I need to go out 1 in each direction and down 1 in each direction. That's what it means to flip, and this will be that V shape. Okay, so this is going great. So now let's just go to the square root functions. Okay, so first things first, does this thing move left, right, up, down? This will move for sure to the right too. And then you also need to flip it. Okay, so first let's just mark that first point. So I go to the right 2, 1, 2. Now, the square roots always throw people off because it's this negative here. But the thing to remember is that your square root always goes this direction. So it's still going to go this direction even when you flip it. So I'm going to go, instead of going out 1 and up 1, I'm still going to go out 1 and down 1. And then I always just want to have it swing in this positive direction. So that's the only other thing you have to remember with that. So why don't you try this one? Hit play when you're ready. So now I'm going to go left 1, I'm going to go down 3, and then I'm going to flip the whole thing. So I go left 1, down 1, 2, 3. Then to get to my next point, I go over 1 and down 1. And I'm just going to go this way since it's flipped. So there's kind of the idea behind this. So I have one other kind of quick exercise I want to tack on to this. Now that we've mastered graphing, we can also go the opposite direction where I can tell you what I want to have happen to the graph, and you should be able to write the function. So in this first one, I'm going to say I want to have the function f of x equals the square root of x. I want this shifted 7 units down. So you're going to write a new function, choose whatever letter you want, and this would be the absolute value of x. So to move it down, I would just write a minus 7 on the outside. So this is a really great test to see how well you really understand directions now. So I would recommend pausing the video and trying these two, and then hit play when you're ready. So for B here, so I've got the graph of x cubed. This totally doesn't even matter what x cubed looks like, you can still do this. So 3 units left and 2 up. Okay, so to move left, that means that I need to add 3 on the inside of the function. So there's moving to the left, and then 2 up is going to look like this. So these transformations are super, super powerful because once you kind of know them, you can apply them to any single function that you want, which is really cool, although I'm kind of lame, so maybe it's not that cool. Okay, so now what about this one? So for this one, so this is the absolute value of x shifted 2.5 units right and reflected over the x-axis. So that tells me then that I need a negative here, and then to shift to the right, I need to subtract off 2.5. So there would be my function. Okay, so I have just 2 more for you if you want to try this one more time, again with some like different looking functions. Pause the video, hit play when you're ready. Okay, so here for D, I want e of x shifted 4 units up and reflected over the x-axis. So the way that that's going to look then, I'm going to just put a negative in front of that e to the x, and then I'm just going to add 4 to the whole thing. So I don't even have to know what that function looks like to be able to draw it. And now here for F, so for this last one, so if I choose a new function letter, we'll use g of x. So this needs to be the cube root of x shifted 3.2 units right, 5.7 units up, and reflected over the x-axis. So this is going to have a negative in front of it. To move it to the right, that means that I need to take x minus 3.2, and then to move it up, I'm going to add 5.7 to the whole thing. So there's your function. So hopefully now you feel like you've got a pretty good idea about this topic. I have lots of other videos like this, so if you've never seen my videos before, I always have free guided notes and lessons and lots of examples. So hopefully this was helpful to you, and